Hello viewers, in this video we will see the solution to week 4 assignment 4 for the course Embedded Systems Design. First one, the bit rate of a signal generated from an 8-bit generator is 3200 bits per second. Calculate the baud rate of the signal. So the baud rate is equal to number of bits divided by the n, that is equal to 3200 divided by 8, that is equal to 400. So this is the formula to convert bits to baud rate or baud rate to bits. So where n is the number of bits of a generator. They have given us 8. So option is 400 baud per second. Second question, I am building a device that takes in digital signals but restricts the input below a certain frequency limit. What kind of filter should I use in the device? So it is a low pass filter, anti-alias filter. You can see here anti-alias filter, low pass filter. Option B. An operational amplifier has following. Third one. So the ideal characteristics of an ideal characteristics of an op-amp: infinite voltage gain, infinite input resistance, zero output resistance, zero noise, infinite bandwidth, infinite CMRR, common mode rejection ratio. So this is for ideal, but practical we'll see. So an operational amplifier has infinite input impedance and infinite input impedance and very low output impedance. So very low input impedance and infinite. So we'll see here. So infinite input impedance. So these two. Out of these two, what about output impedance? Output impedance we can check here. Output must be low. Output impedance or resistance must be low. So output is very low. Output impedance is low, which is option C. The number of comparators needed in a flash analog A/D is analog to digital converter for a 5-bit conversion is, we'll see now. So this is, I'll reduce the size. You can see here now the number of comparator. This is for 3-bit. 1, 2, 3, 4, 5, 6, 7. So it is 2 power 3 minus 1. So the formula that we can use is this one. How to find the number of comparators? So you can see here. So n is the number of comparator for flash type 2 power n minus 1, where n is equal to number of bits. So they have given number of bits equal to 5. 2 power 5 minus 1. 2 power 5 is 32 minus 1 is 31 comparators are required. So the answer is option B. One second. So whatever suggestions we are giving, solutions we are providing, giving are our suggestions. Please kindly note that one, and kindly spend time in going through the solutions before or after assignment submission to get better score, because later you will be very busy with the record submission, assignment submission, and so on, and you will be busy with the end semester examination. So kindly spend few minutes for before or after assignment submission. We'll move on to the 5th one. Calculate the resolution in millivolt for an 8-bit analog to digital converter for a voltage range of 15 volts. So this is 5th one. Resolution is reference voltage divided by 2 power n. So reference voltage they have given 15 and they have given 8. See here, they have given it is for 8 bit and 15 volts. So that is equal to, you will get 15.6 approximately. So the answer is option B, 58. This is 58. 58.6, option B. Sixth question, the frequency of a circuit is F. In order to reconstruct the original signal, the incoming signal should be, so this is very important. So to reconstruct the signal without the reconstruction, okay, without aliasing, so the incoming signal must be less than half of the sampling rate, So the answer is less than half of the sampling rate. Option B. Next, why is the power consumption of a CMOS sensor more than a CCD sensor? CMOS sensors have embedded logic in them. CCD sensors have higher number of DSPs, both A and B, none of the above. Option A. Which of the following properties of the Nyquist criteria are true? We will see that one. So, Fs should be greater than 2 FM, or you can see here, we also know, according to this relation, Fs should be greater than 2 Fn. This is the Nyquist criteria. So the answer is option A. Sampling frequency must be at least twice that of the highest frequency in the signal. Eighth one, how does the delta sigma modulation takes place in analog to digital converter? So it is both A and B can be implemented. See, okay. Next one, quantization is irreversible. So we'll see about quantization. So what happens when you quantize when a signal is quantized, some information is lost because the exact original value is replaced with the nearest quantization level. That means we are rounding off or truncating the values. That's why this means we cannot retrieve the exact original value once it has been quantized. So it is true. Quantization is irreversible is true. Thank you, viewers.